Okay, starting with question 1, what I would like to do is simplify the root 75 and the root 50. So if I write root 75 here, that will simplify down into root 3, root 25, and then from that we can see that will simplify down to 5 root 3. I'm going to do the same here for the root 50, which will give me root 2 times root 25, and then we can see from that will give us 5 root 2. Okay, so now if I rewrite this, we've got 5 over 5 root 3 minus 5 root 2. Now I need to rationalise the denominator, so we're going to times by 5 root 3 plus 5 root 2 over 5 root 3 plus 5 root 2. Now remembering the brackets and FOIL, let's start with the denominator first. We'll end up with, for our first, we're going to end up with 25 root 9. For our outer brackets, we're going to end up with plus 25 root 6. For our inner bracket, we're going to end up with minus 25 root 6. And for our last bracket, we're going to end up with negative 25 root 4. Now for the top, on the numerator, we've got our 5 times each term here, so we'll end up with 25 root 3 plus 25 root 2. Now if we simplify this, we can see that the 25 root 6 and the 25 root 6 here will cancel each other out, so we'll be left with, if I write that here, 25 root 3 plus 25 root 2 all over 25 times 3 from the root 9 minus 25 times 2. That will of course be, if I rewrite this again, that will be 75 take away 50, which will leave me with just 25. We can then cancel the 25s, so we are left with our final answer of root 3 plus root 2. Okay, so question 2 now, using FOIL to expand these double brackets, we'll do a root 11 times 5, so we get 5 root 11 minus root 121 minus 25 plus 5 root 11. Okay, then this will obviously simplify to 5 root 11 minus 11 minus 25 plus 5 root 11, which will then be 10 root 11 minus 36. Okay, for question 3, factorise completely. So we can obviously take an x out, we'll be left with 1 minus 64 x squared. Okay, and looking at this, we should be able to see the difference of squares. So 1 being a perfect square and 64 being a perfect square. Therefore, this we can rewrite as 1, open bracket, okay, 1 plus 8x minus 8x. Okay, therefore our final factorised state will therefore be x, open bracket, 1 plus 8x, 1 minus 8x. Okay, and that's because 1 and 64 are perfect squares. Okay, moving on to question 4. Express 27 to 2x plus 1 in the form of 3 to the power of y. So we need to express 27 to the base of 3, and that would of course be 3 to the power of 3. And then we've got our 2x plus 1 here as well. So if we then expand that, we end up with 3 to the power of 6x plus 3. We're asked the value of y, which is 6x plus 3. So we just need to state that y is 6x plus 3. Okay, and for question 5 here, we can use a quadratic formula. So we need to say the values of A, B, and C. And so for the first one, we've got A, B, and C. So A being 1, B being 11, C being -1. And what I'm going to do is I'm going to do this for A, B, and C, and then we'll get on to using the formula. So here A, B, and C, A, B, and C, and finally A, B, and C. So this would be 2, -5, plus 1, or just 1. And then just do a bit of rearranging here. So we've got -x², -x plus 10. So that will be -1, -1, and 10. And then here we just need to do a bit of expansion and rearranging. So let me do that here actually. So we've got 3x minus 1, 3x minus 1 equals 3 minus x². So if we expand this now, we've got 9x² minus 3x minus 3x plus 1 equals 3 minus x². If we bring that across, we'll have 9x² minus 6x plus 1 equals 3 minus x². So we're going to be adding an x². So we'll end up with 10x² minus 6x, and then we need to take away that 3. So 1 take away 3 will give us -2 equals 0. And at this stage we can now say A, B, and C. That's 10, -6, and -2. Okay, now this part really isn't difficult at all. You just need to remember the quadratic formula. So I'll write that down here. So this is minus b plus or minus the root of b² minus 4ac all over 2a. Now, what I can't stress enough is that you must use brackets wherever you see a variable. So where you see b, a, and c, make sure you use brackets. So for example, for a, if we fill that in, we've got minus, open bracket, 11, okay, because b is 11, plus or minus, we can write that, b², so we've got 11 squared minus 4 times a times c, okay, and that is all over 2a. So the plus or minus obviously indicating that we've got two possible solutions. So then you can just write x equals and x equals, and then do one version where you add and one version where you subtract, and you'll get your two values. And then you just need to repeat that process for b, c, and d. Okay. Okay, and the values that you should get are as follows. So for a, we should be getting minus 11 plus or minus the root of 125 over 2, which works out to be 0.0902, or minus 11.1. For b, we should end up with 5 plus or minus the root of 17 over 4, which works out to be 2.28, or 0.219. For c, we should end up with 6 plus or minus the root of 116 over 20. So therefore we have minus 2.30, or 1.30. And finally, for d, we should have 3 plus or minus the root of 29 over 10, which works out to be 0.839, or negative 0.239. Okay, moving on to question 6, we need to put it in the form px plus q² plus r. Therefore it's asking us to complete the square. So if we have a look at a, we've got x squared plus 12x negative 9 equals 0. So we need to shift that 9 across. X squared plus 12, and leave a gap for the magic number on both sides. Now if you remember, the magic number is b over 2 squared. So b being 12, so 12 divided by 2 would give us 6, and 6 squared would give us 36. So we'd add 36 to both sides. Okay, now here we've got our perfect square, so we can factorise it. So this would become x plus b over 2, which would be 6 squared. This will be equals 45. So if we rearrange that now into the form of x plus q squared plus r, we'll end up with x plus 6 squared minus 45 equals 0. We can then obviously look up here and then finally state the value. So p is 1, q is 6, and r is negative 45. Okay, so moving on to b now, we've got 5x squared minus 40x plus 13 equals 0. In order to be able to complete the square, we need to have a with a value of 1, so therefore we need to factor out the 5. So we have 5 open bracket x squared minus 8x close bracket plus 13 equals 0. So if we now shift the 13 across, we'll end up with negative 13 here. We leave a space for our magic numbers, or our magic number I should say. Then I can copy this down again. Okay, so our magic number being b over 2. So we have 8 over 2, which gives us 4, and 4 squared is 16. So we add 16 to both sides. Okay, and we can now factor this, so it will become x minus 4 squared, not forgetting the 5 on the outside. Now one important thing here we need to remember is the 5 on the outside that you see here will be there to multiply out. What we must remember to do is, for the magic number, multiply that. So now what we actually need to do is do 5 times the 16, okay, and that will change into plus 80. So now we end up with, I'll just rewrite this, 5x minus 4 squared equals, now we need to do negative 13 plus 80, which will give us 67. Okay, and then we need to bring the 67 across, so then we end up with 5x minus 4 squared minus 67 equals 0. So when we're doing complete the square like that and we factor out a number, do not forget to multiply the magic number before you actually do the calculation here. Okay, so this is actually minus 13 plus 80. Okay, and that's all down to this number here that we've factored out, and we can't not multiply it because not doing so will alter the question. Okay, let's move on to C. Okay, so C is here, so we've got minus 2x squared plus 8x equals 0. Now if I factor out negative 2, I've got negative 2x squared minus 4x equals 0. I can rewrite this, x squared minus 4x, leave space for the magic number, so b over 2, so this is a 4 here, b over 2 would be 2, and 2 squared is plus 4, so plus 4 to both sides. I can now factor the left hand side, so I end up with negative 2x minus 2 squared equals, remember not forgetting to multiply that magic number on the other side, so we've got 4 times negative 2, which will give us negative 8. So if I rewrite this now, we've got negative 2 open bracket x minus 2 squared plus 8 equals 0. Therefore, we can state that P equals -2, Q equals -2, and R equals +8. Okay, and finally with D, we've got 3x squared minus x plus 1, x plus 1. So if we just expand this, we've got x squared plus x plus x plus 1. If you remember here, we've got the minus, so therefore we will have 3x squared minus x squared, and this will be 2x inside, so it will be negative 2x, and it will be negative 1. So therefore finally we will have 2x squared minus 2x minus 1. And now rewriting that up here, we've got 2x squared minus 2x minus 1 equals 0. Shift that to the right hand side, we'll have 1. We can then factor the 2, so we'll end up with 2 open bracket x squared minus x, and leave a gap for the magic number, which we'll need to add. And then the b is -1, so -1 divided by 2 will give us half, and a half squared will give us 0.25. So if we write 0.25, okay. So now we can factor the left hand side, so we end up with 2 open bracket x minus half squared. Then not forgetting to multiply that 2 by the magic number, so this is in actual fact 0.5, and therefore we have 1 plus 0.5, which will be 1.5, or we can write 3/2, and then we can simply rearrange that for 2x minus half 2 minus 1.5 equals 0, and we can then state P as 2, Q as -1/2, and R as -3/2, or 1.5. Okay, question 7. How high is the springboard above the water? So how do we address this question? So we've got this equation here, which we're going to rearrange. We've got -10t squared plus 5t plus 10. So springboard above the water, well, when t equals 0, that will give us the height. So if we set t equal to 0, you find out that we get a height of 10 meters. Okay. B. Use the model to find the time in which the diver hits the water. So here we've got a quadratic. Okay, t representing time. We need to find the 2 potential times, or the potential time when the diver hits the water. So we need to set A, B, and C. We've got A as -10, B as +5, and C as 10. We can then use the quadratic formula, minus b plus or minus the root of b squared minus 4 AC all over 2a. And substituting that in, we end up with minus 5 plus or minus the root of 5 squared minus 4 times -10 times 10 all over 2a, which is -10. And then we get two values, which should be x, really should be t. T equals and t equals, and those two values that we get should be minus 0.78 and 1.28. Okay, these are both the three significant figures. So because time cannot be negative, our time in which the diver hit the water will be 1.28 seconds. So just as a fractional surd, we should get minus 5 plus or minus the root of 425 over -20. Okay. C, rearrange it in the form a minus b over bracket t minus c squared. So we're going to need to complete the square here. So if I rewrite it here, we've got our c, so negative 10, and sorry, that should say t up here. Negative 2 squared plus 5t plus 10 equals 0. We obviously need to factor the 10 out, so we can do the following. Negative 10, open bracket, t squared plus 0.5t, close the bracket, plus 10 equals 0. We move that to one side now, leave some space for the magic number. We end up with negative 10 t squared plus 0.5t. And we've got half of b squaring it, so b being 0.5, we can now half that, 0.25, and 0.25 squared will give us 0.0625. Okay, on the left hand side I can do negative 10 open bracket t plus 0.25 squared equals, now not forgetting to times by negative 10, so I will have this as negative 0.625, so therefore this will be minus 10.625, and finally negative 10 t plus 0.25 squared plus 10.625, and values of a, b and c, so a, b and c, well, a would be 10.625. You could rearrange that, but I'm just looking at the values here. Our value for b would be 10, and our value for c would be 0.25. Going to answer D, maximum height of the diver and the time. So if we look at this, what we've got, our vertex, we would have a height of 10.625, and the time would be at t equals 0.25 seconds. This is for D. Okay, question 8, solving these two simultaneous equations. So we've got equation 1 and equation 2. First thing I'm going to do is rearrange equation 1 for x. So that will make it x equals 3 minus 2y. I'm going to substitute 1 into 2, so here's my x squared minus 4y squared equals negative 33. And then I'll have my substitution, so 3 minus 2y squared minus 4y squared equals negative 33. This will then become 3 minus 2y, 3 minus 2y, negative 4y squared equals negative 33. And if I expand this out, so FOIL, I'll end up with 9 minus 6y minus 6y plus 4y squared minus 4y squared equals negative 33. Then tidying this up, I'll have 9 minus 12y equals negative 33. So going up here, negative 12y equals negative 33 minus 9, which will then be negative 42. We can multiply this by negative 1 to give us 12y equals 42. Y equals 42 over 12. Therefore, y is 7 over 2 or 3.5. Okay, now that I know that, I can substitute it into equation 1 because that'll make it slightly easier. So I've got x plus 2y equals 3. I'd like to find x, so just quickly rearrange that, which I'd already done, but never mind. So to find x, it would be x equals 3 minus 2 times y. Therefore we have x equals 3 minus 7. Therefore x is negative 4. Okay, moving on. Question 9. So for A, show that 5y squared plus 3y minus 8 equals 0. Okay, so equation 1, equation 2, I'm going to rearrange equation 1. X equals 1 plus 2y. I'm going to sub this into equation 2. So let me just write 3xy minus y squared equals 8. And then I'm going to substitute this in. So this could be 1 plus 2y. And then there's a y here as well. Minus y squared equals 8. And now I can do 3 times 1 is 3 plus 6y. And there's still y here. Minus y squared equals 8. And then we'll end up with 3y plus 6y squared minus y squared equals 8. 3y plus 5y equals 8. And that should be y squared. Rearranging this into quadratic form, 5y squared plus 3y equals 8. One last step, 5y squared plus 3y negative 8 equals 0. Okay, so moving this up here for B, we've got 5y squared plus 3y negative 8 equals 0. So what we can do is we can see if we can factor this, or we could use the formula. Let's use the formula. So A is 5, B is 3, and C is negative 8. So using the formula, we get a value of y as 1. And this is when we add the root. Okay, and we get a value of y equals negative 8 over 5 when we subtract the root. Now obviously I've done a bit of a shortcut here. If you're going to do the formula, make sure you write the full formula, okay, and you can also factor this as well and find the solutions that way. So now that we've got our two values here for y, we then need to substitute that in to find our corresponding x. So here, what we can do is write x equals 1 plus 2y, x equals 1 plus 2y, and this is obviously x equals 1 plus 2, therefore x equals 3. Okay, so that's a pair of coordinates right there. And then here we can do the same thing. 1 plus 2y, x equals 1 plus 2, open bracket, negative 8 over 5. And we get an answer of minus 11 over 5, which is negative 2.2. Okay, question 10. Here we have f of x. We need to sketch on separate axes the graph of f of x and then f of x plus 3. So we've got f of x first of all. Okay, so we know that we have an x equals 0, an x equals 2, and an x equals 2. So here we've got a repeated root. Okay, and this is a cubic, isn't it? So if we just draw our axes like so, here's our 2, here is 0, and we know it would come up from the left hand side because we've got a positive, so it'll be something like that. So we need to make sure that it comes through 0, 0, and then does a form of bounce, like so. So it won't pass through the underneath of 2, because of a repeated root, it will bounce like so. Now what you do need to make clear is that this is 0, 0, even if it does look obvious, and that this point here is 2, 0. Now looking at part B, again on separate axes. So we look at this translation, f of x plus 3, which will mean that the values that you see here, okay, have shifted by 3 to the left. So where we've got our intercept normally at 0, the intercept will now be at -3, and where it was at 2, it will now be at -1. Okay, so again we've still got our same kind of curve, we've still got the repeated root. So in terms of how it will look, it will pass through -3, dip down, and pass up. Now you'll notice that it passes through the y axis now, the y-intercept, and we need to find out what value that is. Obviously we know the value for that is x, but we need to find the actual y value. So how do we do that? Well, we simply set x equal to 0. So if we look at the f of x, okay, which is x minus 2 all squared, we're actually being told this f of x plus 3. So we need to set it as 0. And if we set that as 0, we've got to add 3 to it. So this is going to be 3, because we're saying x is 0, and then we need to add 3 to it. So 3 open bracket, we're saying x is 0, but we need to add 3, so this is 3 minus 2 squared. So then this ends up becoming 3 open bracket 1 squared. If we do 1 squared, that's 1, and 1 times 3 will give us 3. So when x equals 0, y equals 3, and then we've got our intercept here of 3. Again, you need to make it clear, even though it might look clear, that this is -3, 0. This right here is -1, 0, and this right here is 0, 3. Okay, just make it 100% clear. And moving on to the last question, we have a quadratic. It meets the axis at 1, 0, and 3, 0, and the middle point is 2, -1. Find the equation of the graph in the form ax squared plus bx plus c. So if we're looking at this quadratic right now, we see these 2 points here, so that should tell us that our two brackets, or our two factors, are the opposite. So we've got x -1 and x -3. Now we need to find it in the form of ax squared plus bx plus c. So just before we go and expand this out, we just need to do something else, and that is to place an a here, because we need to find out if it's just x squared or if it's 2x squared. We don't know. So what we can do is they've given us a value at the bottom of the graph, so the vertex of 2, -1, so we can substitute that in to work out some of these values. So if we go by y equals a, x minus 1, x minus 3, and then substitute that value of 2, -1, we end up with -1 equals a, open bracket, 2 minus 1, 2 minus 3, which is therefore -1 equals a, 1 minus 1. Therefore we have -1 equals minus a. Therefore if we times by a -1, we know 1 equals a. So we know for certain now that a in the ax squared is 1. So now we can safely say that the quadratic is indeed constructed of the x minus 1, x minus 3. So if we follow that out, we know that we've got x squared minus 3x minus x plus 3, which simplifies to x squared minus 4x plus 3. Okay, so for part B, on the axis here, we need to sketch f of x plus 2. So we know that our two intersection points are 1 and 3. We now need to shift this -2. So 1 and 3, if we got 1, take away 2, it's going to leave us with a -1. And our 3, if we shift that 2 across, it will leave us with a +1. And if we look at the vertex, that will now become 0, -1. So that's a -1 here. And then we can construct the quadratic, so we'll end up with something like this. Okay, and again, it's very important that we make this clear, that this is 1, 0, that this right here is 0, -1, and this right here is -1, 0. And now for our second graph, y equals 2x. I draw another graph here. We know from the original, again, remember we're referring to the original, not the one we've just done. Y equals 2x, therefore the values of x will halve. So what was at the position of 1 is now at the position of half. What was at the position of 3 is now at the position of 3/2, just to keep it in fraction's sake. And 2 is now 1 for the vertex. So we are somewhere around here. This is being 1. And again, if we connect that, we end up with something like that. Again, make it absolutely clear that this here is 3/2, 0. That there is 1/2, 0. And this here is 1, -1. So take note of how the only the x value is affected, not the y, especially for the vertex. It's quite obvious. It was 2, -1, and now it is 1, -1.